A little bit about me, professor at the University of Iceland. I have had the opportunities to work on several different, I'm not sure if I can use this, but several energy-related projects, ranging from geothermal, maintenance of geothermal power plants, learning how we actually have, in very short time, learned how to be very efficient and running these power plants, to waste energy. So what can we do with the heat loss from both the energy system, but also the district heating system? We're throwing away about 30 degrees of water. What can we use it for? I've also looked at some Arctic problems. So waste is, of course, we call it renewable source. Wherever we go, there's a waste. So how can you use that in the Arctic? Using, for example, looking at gasification, so you can gasify the waste to make electricity and hot water and so on. So I've been looking at many things. That's the beauty or the benefits of being in Iceland. It's so small that you have to be jack of all trades. You have to look at everything. I'm actually now in a project. It's an Arctic project too. It's about virtual power plants. So community-based, so people can pitch in and you have a central battery maybe to everyone can take out. Which, for the last few years, I've been looking at batteries, which is partly my topic, but I will just touch on it at the end. So in my talk, I will tell you about the Icelandic electricity market, the electric grid, and our challenges, at least challenges I'm interested in. There are many more challenges. So here's a pop-up. It's okay. But I will not dive directly into it. I will ease into it, a little bit tell you about Iceland for those who are not maybe too familiar with us. Nothing happens. Okay. So we are located, missing is Greenland. We are located somewhere between Norway and Greenland in the middle of the North Atlantic Ocean. We are not connected by any sea cables, so we have to rely on our own electricity and energy. We, of course, import oil. We are about 400,000 people, getting close to that. Mostly Icelanders, but we have a lot of working force. We would not be able to do everything we do unless we would have people coming in and work for us. So the biggest immigration group is Polish, then we have Lithuanians and a lot of Europeans, but also people from all over the world. 100 years ago, we were less than 100,000. So we've been growing for the last few years. But looking at this graph, it looks like the CO2 emissions in the world. The same graph. So where are we located? Iceland is uninhabitable in the center. So there's a lot of room for things. So we are located on the coastline, but about 60–70% in the Reykjavik area, the big Reykjavik area. And even more here. So you could say we probably are around 80% in this area here. It was not like that many years ago, but people have been moving from the rural to Reykjavik. Reykjavik was about 4,000 to 5,000 people beginning last century. We have 7 universities. The University of Iceland, which I come from, is the oldest, founded in 1911. We have about 14,000 students. Then we have Reykjavik University, which is located on the other side of the domestic airport, so we're separated by airport. They have about 3,500. It's a private university. They pick what they want to teach. We, on the other hand, are public, so we need to teach what the government tells us. A lot of these are not profitable. And then we have smaller players in this. Some of them private, some of them public. So the largest export in Iceland. So this is also numbers from 2017. We had COVID, we're recovering, so the numbers are pretty much the same. So our biggest tourism export is, the biggest export is tourism. So what do we sell? We sell scenery. So if you want to see something nice, you can enjoy walking, and this, people have loved this. This has been used in movies like Game of Thrones or Star Wars, and they like these black beaches. But yes, people tend to like to come and see this. So we try to provide service like good restaurants, and so actually restaurants are becoming very good, so I'm happy. We also start to make our own local beers, which I am also happy with, which would not be possible if we would not have about 2 to 3 million tourists every year. Then export is seafood, fisheries. This has been our building block for many years, but it's getting less, has a less percentage. And then aluminum. So you mentioned aluminum. So it's not like we have aluminum in Iceland, but we export a lot of aluminum. So it's imported bauxite, we smelt it, and then it's exported for further processing. There's no processing, it's just smelting. This is our way to export electricity. We have no sea cable, so we sell the electricity to those companies who do this. So it's not owned by Icelanders, it's big companies, and they use our electricity to process this, and then they take it to further processing in their own plants. So our electricity, where does it come from? About 70% is hydropower. And then we have about 30% geothermal. We have been experimenting with wind. I will tell you a little bit about it later. And we also, there's a pop-up, we import oil, but that's mostly for backup power. So if we have problems, we can run diesel to help us. So, yeah. So the geothermal, yes. So about 99.8% of our electricity is green renewable. The rest is oil. So the government has this goal of becoming greener, and they have like said, okay, we want to reduce the CO2 emissions, so what can we do? Well, cannot really attack the electricity generation. So they promised to turn our transport into green. It is, of course, very difficult to change human behavior. We like what we do, and so it's probably not up. It's an uphill battle, we could say so. But they have made incentives and so on. So last year, it's been interesting. Last year, we had about 10,000 electric cars imported. But for many years, we've been importing hybrid and plug-in hybrids. And people still like them because they want to be able to travel around Iceland. But we've also been installing charging points around Iceland, and we have way more now. This is like a 2-year-old image. And so you can travel around Iceland and charge your car. But there's something in the mentality of Icelanders, they want to go from A to B. They don't want to stop on the way to charge. So that's why they always look at the car has to have a mile range of 400 and 500 kilometers. So you can go from Reykjavik all the way to Akureyri. It's about 400 kilometers. But there are, of course, many ways they can stop and charge. But there's something in our mentality we're fighting. But the so we have about 10% of cars now electric, and 18% are like some kind of hybrid. Some of them are also methane. Less of buses, so 1%. So the big cars are not electric, but there are now about 20 hydrogen trucks on the way. There are companies that have signed agreements to use hydrogen. So now I want to tell you a little bit how the electric grid has evolved in Iceland. So if we start 64 years ago, there was no electric grid. So we were had local grids. So Reykjavik area here had one grid, and then we had a lot of scattered local grids. But then there was like this incentive, or not like a master plan to connect them. And then fast forwarding 20 years, we had the first, say, sign of what we call the ring line, to have a power line here connecting through everything. And then we have added few power plants. And for each of these power plants, most of them are hydro. And for each hydro, we have always made them for big industry. So here you have aluminum smelter, here you have a ferrosilicon plant from Iceland in Norway. So for each, we made a hydro plant. So the big industry has helped us build up the grid and the plant. So we always do this for some customers. Our first geothermal power plants here in the north. So my professors, my advisors, they were heavily involved in this. I remember this, they had all kinds of stories to tell us and also some equipment to show us, because there was a lot of learning, steep learning curve here. Because in the geothermal power plants, we use turbines that are made for example, nuclear or coal, which is using clean steam. We're not using clean steam. We take it directly from the earth. It's full of minerals and ugly stuff, acids. And so the turbine blades erode and they go quickly. But throughout the years, in good collaborations with those who make them, we have been able to improve the materials used. Now, going 15 years forward, we completed the ring line and added even more power plants. Looking for the customer paying for it, but that's it. And then, of course, what we did slowly and slowly, we also increased the power plant. So, for example, Búrfell here, it's 210 now. Then they increased slightly, so now it's 290. So slightly we are adding. But going 2016, now we have more geothermal power plants. We have one here in Reykjanes, Svartsengi. I will tell you a little bit more about in next slides, but that's a 75 megawatt power plant, but it also has a 150 megawatt thermal energy. So it provides hot water for Keflavik and part of the Reykjavik area. But Hellisheiði, that's another power plant here. This is the one providing the thermal heat for Reykjavik. So everything is heated by hot water coming. So first we use it through the turbines, then we heat up cold water, and we heat up the city with the same water. No, sorry, with the cold water heated with the water coming from the power plant. Here we have a big plant. This is by far the largest one, so 690 megawatts, and the customer is here. It's aluminum smelter. But this one, I remember my professor said, I haven't really looked into it, but he said it's on the scale of Hoover Dam, but way less power. So the fall that the water here is more than Hoover Dam, it's about 600 meters in steps, but it's quite high up in the mountains. So here's just a quick overview. This is exactly today, but nothing much here I wanted to tell you about. But we have throughout the years, and we can trace this back to the beginning of the motorboats in Iceland. So very early, we sent the government sponsored few young men to go to Germany and Denmark to learn how to repair and maintain engines for the motorboats. And that's the start of the whole motorboat fishing industry in Iceland. But then when they came back, they made machine shops around Iceland. And not only maintaining the ships, they started to harness the power of the waterfalls and the rivers. And so slowly they were building up small electric powerhouses like this. And some of them actually made series, so the same river is used again. So you make one, and then a few hundred meters you make another one, so you're reusing the same water again and again. So this is a list of all the small power generations listed in Iceland, some of them decommissioned, but we still maintain a map of them. And right now we only have 2 solar registered. I'm number 3, not yet registered, but now is a steep learning curve because we don't know anything about the whole thing of building codes and fire department and what they want and what they require. There must be a switch here because they don't want to go through 1,000 volts. And so a lot of things we are learning now. And I allowed them to use my cabin in my backyard as a test case. So we are running now, going through all the officials and having them giving us answers as how to do things correctly. But there is a lot of interest, especially public, like we could say governmental institutes and so on. They want to look green. And one way to look green is to put solar panels. We're running on renewable energy anyway, so, but if you want to look green, this is the way. So they have also mapped out the possible where we can increase the capability of the grid. So this is more or less existing power plants, but we can squeeze out 10 to 30 megawatts from each and every one. Here's a new one that could actually be used, but then we're adding 150, 200 megawatts. Missing is, very interesting, we have been running for 11 years, 2 wind turbines. Those are the 2. They've been running here. There have been other wind turbines in Iceland, but they all failed because we have so extreme wind. Even in just Reykjavik, we have easily 70 meters a second wind bursts, so not steady wind. So we've had few of them just collapse, but those are still standing. And this is the National Power Company Landsvirkjun running them here around their own hydro dam. And now they're planning to put in a farm, so about 120 megawatts of 30 pieces of them. I like this image. I stole it from the website because you could look at that. This is lupin. We planted this in 70s. It was supposed to help us with the erosion of the land, and it was supposed to find the soil, and then another plant would come in and take over. But the lupin is still there. So it's an invasive species. It's distributing, like we have no control over this. It's going everywhere. A lot of people see the wind turbines as the same. If we allow this, they will spread out everything. So we have this environmental agency protection. So I will show you what they think. But it depends on the point of view. So the lupin is here. So if you like, it looks very nice, the other image, but there is almost nothing here. It's not beautiful. But if we give them the little finger, they think that the rest of Iceland will look like something like this. They're warning us about this. So, and there's a lot of people against it. We don't want to see this. Remember, tourism is about 42%. So we would also be destroying another valuable export business. Iceland is located on a ridge. So we are on the top of 2 tectonic plates. So it's North American plate, Eurasian plate, and then there is some independent plate. Luckily for us, they're pulling apart. So that means we are like growing slowly. If they were coming together, we would have so many earthquakes. But this area here is where we have the geothermal potential. So we have power plants here, we have power plants here, and there are plans to do more. But we had a really interesting project, European sponsored, very expensive. It's called Icelandic Deep Drilling Project. We always want more. So the idea was to drill down to the magma chamber, close to it. Put water in there and get supercritical steam up, getting a lot of power. So they did experimental here, accidentally drilled into molten rock and had to stop. So they started a few years later and they're continuing. So, but this has a very high potential of giving us high energy if we go very close to the magma chamber, but we have to be careful. The electric system and the whole overview of it, this slide here summarizes more everything. So for generation, we have these companies here. This is Landsvirkjun. They run more or less all our hydro dams. This is owned by the government, this is municipalities, and also public. This is the only private, and we don't like it. We don't want the energy companies to be owned by private. That's just in our. We want this. It's our nature. It's our energy. It should be run by us. But somehow this one slipped out of our fingers. Then we have the TSO, transmission operator, called Landsnet, that connects those producers. And you see Landsvirkjun produces 71%. So 5 generators with 5 distribution networks. Those are the networks. And then we have been adapting to European regulations. So now we've split up the generation and the distribution. And there's a new layer here, it's resellers. They don't do anything. They just take commissions. Well, some of them are actually owned by the same companies here, but we have new players. Like this is just a startup company with maybe 20 square meter office. And I'm buying electricity from them. Just an experimental, because they're now starting to offer me cheap electricity during the night. And I wanted just to try that. Later on that. But so then general market is about 28%, the rest 72% are big users. And they do not go through the distribution, they go straight from the Landsnet TSO that has connection straight to them. And they all have a very special deal. It's 72%, more or less everything from this company. So when we make big hydro dams, it's those companies who are paying for it. We make them for them so they can get, and they get very good deals on the electricity. What we pay in homes, the retail market here, we pay about 5 to 7 euro cents for the kilowatt hour, and it's fixed. It's no spot market. And so we are buying from these, and that depends who you're talking to, whether they have 5 or 7 euro cents. Then we pay the distribution about 5 to 11 euro cents. But that depends who you're talking to, and if you're in rural, outside of like cities, then you pay more. So it's cheaper to be in towns. And so the total cost is somewhere between 10 to 18 euro cents per kilowatt hour. And then there's some creativity, always some creativity in the energy sector. If you want a guarantee of origin that your electricity is green, then you can pay 2 euro cents. So the government, now these companies, they've been selling the certificates to someone in Europe. And then companies have been claiming we're using renewable energy. And then they've been like, you cannot do it twice. You cannot sell this to a company and then someone else claims he's using a renewable energy. But we are. So now they've come where you have to pay for so that you have a certificate. So if you're producing, for example, food, and you want to say your food is made from renewable energy, you have to add on this, even though you are using renewable energy. It's funny how things work. Last year, so those are actually official numbers from the TSO, but the last year, it was just 2 weeks ago, turns out the data centers in Iceland are using about 5% of the total energy. I asked them, how is that? You gave me 2%. They said, well, they're going through those also. So 2% comes from the TSO, but they're buying from other sources as well. And this is the first time they exceeded all the homes in Iceland. So the homes are about 5% like that. The rest is just small industry. Small companies, but some of them are bigger than others. So we have a tariff on them. So if they use more than 500 amps, we take the 4 highest hours. So we look at how much they use the energy. So we take the most energy intensive 4 hours, 1 a month, 4 over the year, and they pay extra for that. And that's one of my challenges I would mention now in a few slides. It's this capacity tariff that is actually can be a very high burden for some companies. You only need, let's say, few peak hours, and then the rest of the year is very expensive. So, 2 challenges. So the challenges that I'm interested in. One of them is unstable grid. So we have in the northern part here, during the winter, very bad weather. So occasionally, for example, here in Westfjords, this is a weak line here, this tends to go off. And then what they have is about 6 diesel backup generators, each with 2.5 megawatt ampere. They've not been planning to replace them, but what they're interested in is bridging the gap from starting them until they're fully operational. So 90 seconds. So the experience of the users, they will see the transition from the grid to the backup generators. So I've been working a little bit with the TSO, looking at possibilities, but this is very expensive for them. Another is this area here. You see where the grid is, the rest is local grid. There's a lot of farmers here, small towns, and the farmers do not like to be without electricity for 2 or 3 days. They have animals and everything. So they've been coining with this idea of maybe having batteries. There could be portable stationary batteries in containers. We could bring them over just to have them. So that's also what I've been working with. There's an entrepreneur here is really driving that, and I'm working with him. Now, Bo mentioned EV charging, and same in Iceland, our electric grid was not made for EV charging. So this needs to be reinforced. Of course, the grid needs to be upgraded, but this market, this whole technology, it's in its infancy. We don't know where it's headed. So it's really difficult for us to start upgrading the grid right now, because in 5 years, we might be going somewhere else. So right now, we could reinforce this with batteries to take the peak. But there's also another way. There are some of the charging stations can be directional. So you could actually use the batteries in the cars to help you a little bit balance the load. But that's, you could say, unsecure. It has like intermittent storage because someone wants to take the car and drive away and you lose that energy. Another big problem, a challenge, is the onshore power. For fishing ships, no problem. We connect them to the grid when they are docked, but it's the big cruise ships. They like to be at the port running their diesels, and there's a lot of pollution. It's actually very much pollution. But they also need a lot of power. It can be 1 megawatt ampere up to 10 megawatt amperes that they need. And building new power lines to feed them will be very costly. And there's also a question of payback time. We might have them for a few years and then they're gone. They decided Iceland is not interesting anymore, and you might go to Greenland. And so you're stuck with the cost. So battery storage that can actually be portable, so you could actually follow one ship. If it wants to stop in 3 places, we just follow you with the battery. That's one idea, but we're still looking into this. But the EU has regulations aiming to, in 2030, again the same year, to have them not running their auxiliary power while docking. We did this in Iceland many years ago. If you look at this differently, with the hot water. So if you look at battery storage, it's just storage of energy. We did this with the hot water. So if you go to Reykjavik, you will see this above. Those are water tanks used to store our hot water. And so when we needed like high demand hours, we could tap off from those. We're not using them anymore. Technology has evolved. Bigger pumps, bigger everything. Everything is now more or less just at the power plant. Same maybe with the EV, everything. We don't know where the technology is heading. And instead of going into huge infrastructure, we could maybe wait a little bit and use batteries at the same time. 2 challenges more. One is the oil that we're using. We're using a lot of diesel generators, and some of the diesel generators are backup. And if you add batteries to them, you don't have to run them until the battery is close to be like empty. And many of them are not run with batteries. So if you turn on a light bulb, let's say just for extreme LED, 5 watts, you have to run on a diesel generator. But if you have a battery, you can run the battery for a long time until you turn on the generator. And if you have the battery, the generator can be run more efficiently and then turned off instead of just running for 5 watts LED bulb. Last year, we imported 12,000 liters for making electricity of oil, but that was an extreme year. Years before, it was about 7,000. So you remember I told you about the energy tariff. So companies that are using more than 500 watt amperes, they pay for the peak load. So they could use battery energy system to basically shave off the peaks, so they pay less money for that. And that's actually a very, very, very good case, and a lot of companies are interested in this, because they can immediately see the benefits. So the last challenge I want to mention, and it's actually right now ongoing, volcanic activity. We have an eruption right now, started last Friday. First, a little old move is from December, I think, this year. So we have cracks opening up, and the lava goes up and goes into town. This was a total surprise for us, because we had all the geologists and everyone helping us try to understand this, but they did not see this one coming. I will show you where it is in a few minutes. But this is another view of the same thing. And you can see a lot of machinery working. So we are trying to control where the lava flows, making like, what do you call that, like walls, big walls, to steer the lava away from the town. This town is called Grundarvik. And yeah, so we are using our biggest machinery for this. Our challenge, you see, this is all lava. Here And this is where we project that the eruption that started now 23rd of August, where the lava will go. Here we have our power plant, Svartsengi. And Svartsengi is 75 megawatt electric and 150 megawatt thermal. And here we have a big tourist attraction. This is the Blue Lagoon. And so both of them are located the same. Actually, Blue Lagoon is the wastewater from the power plant. You pay for it, you want to swim in it, and it's good and healthy for you. It's good water. But what you see here, those are our protection barriers. We're trying to steer the lava. You see, this one is big here. We're trying to protect this one and here. And there's a big controversy here because this is the only power plant that's owned by a private company. So why should we pay for all this work to protect a private company? But we're also protecting us because we will lose a lot of energy. Yeah. So this is the Blue Lagoon. This is the power plant, and the wastewater from the power plant fills up the Blue Lagoon. People swim in this. It's healthy. So there's algae. So this is a seawater goes through, and in here, this is Grindavík. This is Reykjavík on the other side. There's a bay here between us, and you see the Blue Lagoon is and the stuff is over here. So it's very close. And then we had this surprise eruption that I started with. Inside the barrier, it started here. So it was a big surprise to everyone. And like I said, we are using our biggest machinery. They don't look big when you look from afar. But we've been spending a lot of money trying to protect, steer the lava. But it's all about guessing, where does the lava come up next time? And one time, this is just from TV, we saw the lava going over the hot water pipes. And then we had this rush of steam coming up. That meant no hot water for Keflavík and the surrounding area. And they needed to heat up with electric heaters. But the electric system was not made for heating with electricity. So they had to ration it because the system could not deal with this heating. So you can see it's not good for the cars. So that's the challenge. So battery in town just to reinforce, if you have cases like this, that would be very good. We're also using the opportunity, so the TSO, so we estimate that next eruption, probably this that's currently now ongoing, will be flowing lava here. So they're putting up all kinds of tests. They want to see, for example, if lava goes to the transmission lines, what materials can withstand, and so they're installing all kinds of tests, see how it will handle the lava that comes, just to learn to protect ourselves in the future. So we're using the opportunity as this is a living lab, just learning this real stuff. Yeah, and it's mesmerizing. So they have it on live. You can see it on web cameras, and you can just look at this for hours. And slowly, this is just running on. It is beautiful, but it's of course dangerous. We've had a lot of. You can find it on YouTube. Quadcopters flying over this. But the interesting is that the magnetic field is disturbed, so you have to fly manually. They lost a lot of quadcopters first into the lava. They learned the hard way. So while I still have your attention, I'm going to stop. So thank you for the attention. Thank you. Yeah.
So I have about 16 kilowatt solar at home.
Yeah.
And my question is, am I bigger than all the solar plants on Iceland?
No. No. You're bigger than me. I have 4.3. but IKEA had 17.
Oh, okay.
It was donated to University of Iceland for educational purposes. But the dealership for Volvo has 20 kilowatt.
Okay.
Yeah.
Okay, but I also have a serious question. When you talk about unstable grid, is it more the grid itself? So the capacity and the frequency, voltage and stuff like this? Or is it that you have unstable power generation?
It basically just cuts off the line. It's blackout.
Okay.
It's not like unstable in this way. It's just, it goes out.
So it's not that resilient.
No, exactly. Yeah. It's because of bad weather. I mean, you combine everything, really high wind speed, snow and everything, and then something happens. It takes them sometimes 1 or 2 days to fix it.
Then maybe add-on question, since you have so much hydropower generation, I was actually a bit surprised. I thought the geothermal was a bit higher. But is it basically only running water, or do you have like on Greenland that you have strategically placed reservoirs that you also have?
It's big reservoirs, and that makes them very controversial.
Okay.
Yeah, so the big one that we have 690 megawatts, that was a huge fight. They were like, you had 2 groups like clashing because you had to flood so big area of land.
Yeah.
And the farmers around that area, this is a part of Iceland where we have reindeers. If I can go back. And so there's a lot of, there are farmers in this area here, so many fjords here. So in this area here, we have reindeers and stuff like that. So you're damaging a very nice environment, but the argument was, no one is there. But we are there, we live there. So it was a big fight, but of course, in the end, it was made. We have this master plan of where we can put, the government has made this master plan, so where to put power plants. But there's a lot of resistance towards, because who is this power plant for? Some greedy rich people, big industries from coming abroad. So this is now the sentiment more than in the old days. Yes, we need more power, but now we're thinking the nature, who is it for, who is going to benefit from it. So it's like we're thinking differently a little bit. And then there's this wind turbines that actually people don't like.
It's a little bit related to the wind turbine and the voltage, right? Because how is the ice cap you have in these areas influenced by climate change? I mean, if you look forward 5, 10 years, and if we have an increase, let's say 2, 3 degrees, maybe 4.
Yeah.
I mean, how do you believe what will happen to the hydropower?
I think as long as we keep getting rain, they're all very dependent on rain. So sometimes we get Landsvirkjun warning us, it's been very dry years. So they're cutting down energy to selective customers. So you can be a customer that you pay premium, that means you always get your power, or you can get, you pay less, and then you have like uncertainty. If they need to cut down, we will cut you down. And that's why we have the increase in oil from 7,000 to 12,000. Because some of the fishery, like the fish processing companies, they pay lower quality energy. So they had to cut them down, and so then they used diesel. And then they start to complain. But they selected this. It's been benefiting it from years, but now
that was probably what relates now what I want to ask about wind and solar, right? Because is that, and of course I don't know the regulations of on Iceland, but for fish factories, for instance, if they took their whole surface, plastered it with solar, I assume they would be able to then benefit from that.
Yeah.
I mean, during the summer where you don't have any night.
Yeah, we have 24 hours and 24 hour daylight, and especially here, you actually have sunlight in the very north during 24 hours. And that is one of our biggest fish export that is considering a huge solar farm.
Yeah.
They're looking into it, yes.